So let's start with chapter 2, vector algebra. So the first sum here is example 2.6. So we are going to use do the scalar product first. So this is ideally a 3-mark question. That is, in 6 marks you will get sometimes 2 3 marks as 1 6 marks. So this could be one such sum. This is a very straightforward sum. For any vector r can be any vector, you have to prove r vector is equal to r dot I into I, r dot j into j plus r dot k into k. So let's get started. So he says for any vector r, right, for any vector. So the first thing that you can do is you can assume r vector to be any vector, right. So let us assume to be xi plus yj plus z into k vector, right. Now this is the assumption we have made. Now what are they asking us to do? They are asking us to do, so let's check the right hand side, right. We have to do r into I vector. R dot, not into, it is r dot I vector. So this will be nothing but r, we assumed it to be xi plus yj plus zk, right. Now I have to multiply it with I vector. So whenever we are doing the scalar dot product of two vectors, you know that only the even vectors will multiply. That is, you can multiply only I and I. So here it is x into 1, so it would just be x. So there is no j vector here, or there is no k vector here, right. So then the rest will be 0. So the value is just x. So likewise shall we do for j vector and k vector. So for r dot j it will just be, there is no I component here, there is only a j component. So y into 1 y. Likewise let's do for z, sorry, r dot k vector. So now it is k vector, r dot k vector into, right, so it's xi plus yj plus zk into k vector. So you can only multiply this and this. So the answer is z. Now in the right hand side you also have to now multiply each of this with I, j and k. So r dot I we already know it is x, right. So it becomes xi plus r dot j is y, so it is yj plus r dot k is nothing but z, and z into k vector, right. So this whole thing is nothing but our initial assumption, which was r vector, and this is what you have to prove, right. So it is proved, right. It's a very easy 3-mark sum. All you have to do is assume r vector to be an arbitrary vector xi plus yj and zk, and then keep following whatever is asked in the right hand side. You will fall into the answer.